Hello everyone, welcome back. I hope you're all doing well. I'm now going to do the videos going over homework 7. Now the homework 7 is on Moodle, and also the answers will, not at this moment, but I imagine by the time most of you are watching this video, will also be posted to Moodle. I would urge you to work on this, struggle with it before looking at the answers, before looking at this video. And also, if you got the right answers, you can skip the videos on homework 7. I mean, I've presented a lot of examples in the 2 series of videos. So if you have it down, that's fine. But that said, these games are difficult, so don't feel bad if you're missing things. That's why I'm doing a lot of videos. I would have spent a lot of class time on this. I imagine in the class time I would have taken a lot of questions, and these kind of games are, they're quite challenging. So let's go over this class of games. So remember, there are 4 decisions that we need to figure out, right? We need to figure out player 1 if he's a lefty, player 1 if he's a righty, player 2 if player 2 is told up, and player 2 if player 2 is told down. And there's a few tools we can use to solve these games. And the first one, always we should check for dominant strategies, because remember, if you have a dominant strategy, it means you should do it regardless of what the other person's going to do, right? And that's great. That means you don't have to figure out what the other person's going to do. Just go for it. So let's check for all 4 possibilities, all 4 of the moves. Let's check for dominant strategies, and then we'll build from there if we can. All right, player 1. Nature says you're a lefty. Do you have a dominant strategy? Up gives you 9 or 9, so up gives you 9. Down gives you 6 or 6. Well, of course, this is an obvious one. You want to go up, and that is a dominant strategy, so I'll put a D on it. What if you're a righty? Up gives you 0 or 0, so, 0, whereas down gives you 2 or 2, so, 2, because 2 is definitely bigger than 0. Okay, that was relatively easy. What about for player 2? Well, you're told up. If you knew you were here, you would want X because 5 beats 0. And if you were here, well, you'd want Y. So there is no dominant strategy for player 2 if up is played, because player 2, if you're told up is played, you can't figure out what you want to do until you figure out what player 1 has done. So you try to figure out, you need beliefs about player 1 before you can figure out what to do if your player 2 and up has been played. What about down here? All right, down is played. Player 2 would say, if I knew I was on the left, I would want Y, and if I knew I was on the right, I would want X. So no dominant strategies for player 2 if down or up is played. But we can use the fact that lefty has a dominant strategy of up and righty has a dominant strategy of down to pretty easily figure out what player 2 should do. Because remember, the first tool is play a dominant strategy if you have one. The second tool is figure the other person's going to play a dominant strategy. So you're player 2 and you're told up has been played. The way you got there was nature went left, player 1 went up. You're here, and if you know you're here, X beats Y. So you definitely want to circle this X. And then you got to circle both, because remember, your move is, you're doing the same thing at both. But you can do something different down here than up here, but you got to do the same thing here and here. In any oval, which represents uncertainty, you got to do the same thing, the same move, every decision node in the oval. Well, if down is played, you're told player 2, hey, I've moved down. Player 1 says that. The only way you got there was boop, boop. And that way, you're here, and if you're here, you want X. This X is different than this X. These are not dominant X's, right? This isn't dominant because you're only doing this because of what you think player 1 is going to do. Player 1 is picking this up and this down without having to think about what player 2 might do. All right, and now finally, we need to circle where we end up, and we know that. Nature goes left. Player 1 goes up, player 2 will pick X and will end up here. And if nature goes right, player 1 goes down, and player 2 will pick this X and will end up here. So the equilibrium for this game is if left, we end up here through this route, and if right, we end up here through this route. So, sometimes I'll be asked, like, is there one equilibrium or two? This counts as one equilibrium because the equilibrium is resolved before we resolve the probabilities. So when I say the equilibrium, I mean, without knowing what nature does, this is what's going to happen, conditional on the things that nature might do. So this game, pretty straightforward. Oh yes, and remember, this is a separating equilibrium. Remember, in a separating equilibrium, player one does something different depending on if he's a lefty or righty. So the two types of player one separate themselves. Player two realizes it, so player two has no challenge at all of figuring out where he is. So player two says, I can observe you, player one, but I can't observe what nature does, but I can observe what player one does, and my observing what player one does basically tells me player one's type, and so when I move, I know what I'm doing. I know where I am. Again, separating equilibrium. All right, let's go on to game two. So, let me see here. Alrighty. So, game two, for problem set 7. And please, I hope you've done these on your own. Tried. It's okay if you didn't finish, didn't get it right, but at least tried. All right, so look for dominant strategies. I know it's getting boring hearing me say that, but that's what you need to do. So if player one is a lefty, player one will say up gives me 0 no matter what, whereas down gives me, 3 or 1, more than 0. Player one is a lefty, he definitely wants to go down. And what if player one is a righty? He'll say, up could give me 8 or 5, down could give me 9 or 6. So does player one, if he is a righty, have a dominant strategy? So say it, your answer. Does player one, if he's a righty, have a dominant strategy? What do you think the answer is? The answer is no. Because, it's true, 9 is bigger than 8 and 6 is bigger than 5. But player two can do something different up here than down here. So the reason down is not dominant is because quite possible down would lead to y, whereas up would lead to x. Player one, if he is a righty, does not have a dominant strategy, and before a righty figures out what he wants to do, he really should figure out what player two is going to do in response to up and down. All right, now let's consider player two. Player two, you're told up. If you knew you were here, you would want y. If you knew you were here, you would want x. No dominant strategy for player two if you're told up. What about for player two if you're told down? Well, if you knew you were here, you would want x. And if you knew you were here, you would want y. Okay, no dominant strategy for player two if down is played. So we figured out one of the 4 pieces of our puzzle. Next step is to see if we can build on that. The next tool officially is player two will recognize that lefty has a dominant strategy of down. And this provides a big hint if player two is told up. So player two, let's say, has solved the game up to the extent we see right here. And player two has said, okay, if I'm told up, and I might not be, player two would say it's perfectly possible from what I know right now, from what I figured out right now, that everyone's going down. But if I'm told up, I know there is no way lefty did it. So if I'm told up, I bet I'm on the right. I bet the only way I get here is this path. So if I'm told up, I bet I'm here. And I know exactly what I should do if I'm here. I want x. Got to circle both x's, of course. Now this second piece of the puzzle makes it, it doesn't make it obvious what righty should do. Because now righty will say, if I go up, I get 8. Down, maybe I get more than 8, maybe I get less. So had player 2 wanted to do y if up is played, then we would know player 1 if righty would go down because he can't do worse. But unfortunately, this doesn't solve what we're gonna want to do down here. So let's think about this some more now. We know up gives you 8. We know player 1, if down is played, well, he'd be willing to go down if it was X, but would not be willing to go down if it was Y. And what about player 2? Player 2 will say, well, if it's X, I could get 6 or 0, and if it's Y, I could get 7 or 0. So let's go to the take a chance. So we're going to say, I'm not sure what's going to happen. Let me consider equilibria where up is played. So in an equilibrium in which up is played, what would happen? What would player 2 do down here? Well, if it's an equilibrium in which the only person who goes down is lefty, then you definitely want X, right? If you know you're here, you want X. Is this an equilibrium? Well, no. Righty is not really happy because Righty is saying, equilibrium, I'm expected to get 8. But had I not gone along with it, I would have gotten 9. This makes me unhappy. So this is not an equilibrium, right? And the reason it isn't is, remember, in an equilibrium, everyone has beliefs that turn out to be accurate, and everyone's behaving optimally given their beliefs. So for this to be an equilibrium, Righty has to believe that player 2 responds to down with X. And Righty has to say, I want to go up. But you're Righty, and if you think player 2 responds to down by playing X, you are not happy going up. So this is not an equilibrium. All right, we've proved there's no equilibrium in which Righty goes up. Might there be an equilibrium in which Righty goes down? Let's investigate, and I'll do that by putting a triangle. Let's just consider. All right, Righty goes down. Now we have to resolve, we have 4 things. We figured out 2 of them from before, this dominant strategy, and then we figured out this occurs because of this dominant strategy. We've got to figure out finally, how does player 2 do in a pooling equilibrium in which everyone goes down? Well, if you play X, you get 6 half the time, right? And 0 half the time. And if you play Y, you get 0 half the time and 7 half the time. Obviously, better to play Y. Again, these were not 50-50. It wouldn't necessarily be Y, but they are. Okay. So I've shown if there's an equilibrium in which Righty goes down, player 2 is going to respond to down with Y. Let's go through. Is everyone happy with this equilibrium? Got to check the 4 positions, see does anyone regret. Player 1, lefty, you never regret a dominant strategy, not a problem. What about Righty? In the triangle equilibrium, Righty is going down and getting 6. Had he gone up, he would have gotten 8. He is not happy. This is not an equilibrium. So this game does not have an equilibrium. Again, it will if we allowed mixed strategies, but we're not. So answer, no equilibria. Thank you.